Hello everyone, this is Alistair here, and today's problem of the day is titled Smaller on the Left. So, in this problem, you are given an array of n positive integers, and your task is to find the greatest element on the left of every element in the array which is strictly smaller than itself. And if this element does not exist for an index, then we have to print -1. So, for 2 here, we have no element which is smaller, and basically there's no element to its left. That's why we have printed -1. For 3, there's the element 2 which is greater and also smaller than 3 itself. That's why we have 2 here. For 4, we have the greatest element as 3 and it is also smaller than 4 itself. That's why we have 3 over here. For 4 again, similarly, we have the greatest. For 5 again, similarly, we have the greatest element as 4 and it is smaller than 5 itself. That's why we have 4 here. But for 1 here, there's no element which is greater whilst being smaller than 1 itself. That's why we return -1 here in this case. Now, in order to go over the problem, what I can do is I can simply maintain an array and keep a track of all the elements which is present to the left of the considered element. Let's say for 4 here, for 4 here, if I had 2 comma 3, then I'll be checking if there exists any element which is smaller than 4, and we have to basically find the greatest element which is smaller than 4. So we get 3 here and we'll simply mark 3 as a corresponding result to the element 4. So as and when we come across all the elements, we'll be storing that in the array, but we need these array in the sorted order, because if we want to perform search in an unsorted array, then it would take us O of n time. But since we have to present the result in n log n time, we have to somehow modify this array, and we can perform the search in O of n log n time only if this array is sorted, and this sort would take us O of n log n time at max. So in order to avoid all this, what I can do is I'll simply make use of a set, and I'll use the lower bound method within set, which would make use of binary search, and it would provide me with the iterator pointing to the element which is greater than or equal to the value passed. So it can point two types of values, that is either the end variable, which is a special variable pointing to the end of the set if it does not find any element, or we could receive an iterator which points to the value itself, that is the value equal to the value passed, or it could point to any value which is greater than value. I mean the first value which is greater than value itself. Let's consider an example. Let's say we have an array 2, 3, 2, 3, 9, 8, and 1, and we'll also maintain a result vector or an array wherein we'll be storing a result corresponding to each of the array elements. So how we'll be solving it? We'll move across the array. So the first element here is 2. We'll consult the set using the lower bound method. Sorry, it should be lower bound and not lower value. Yeah. So we'll consult the set. We'll pass in the value 2 to the lower bound method. And on consulting the set, since initially the set is empty, it will point me to the beginning of the set. And since it is pointing to the beginning, means there is no element which is which is smaller than 2 whilst being which is greater than no element which is simply like present to the left, and it is smaller than 2. That's why we'll enter -1 over here, and after doing this we'll simply place 2 here in the set. Now coming to the next element, which is 3, we'll consult the set again using the lower bound method. We'll search for any element which is greater than or equal to 3. So here we have the element, we don't have any element which is greater than equal to 3. That's why the iterator returned by the lower bound method would be pointing to the end. Since it is pointing to the end, what we'll do is we'll decrement our iterator once and return the value received by the iterator. So on decrementing, we get 2 here. That's why we'll push back 2 in the result and we'll enter 3 here. Now coming to 9, we'll again consult the set. There's no element which is greater than or equal to 9. That's why the iterator received would be pointing to the end. And since that is the case, we'll decrement our iterator and we'll receive an element which is smaller than 9 but greater on the left of the 9 array, like greater to the left. So that's why we'll be returning 3 here and we'll enter 9 in the set. Now coming to 8, we'll consult the set again, but here there's an element which is just greater than 8, which is 9. So the iterator will return a pointer pointing to 9, and since lower bound returns an element which is just greater than equal to 9, we'll simply decrement that iterator, and on decrementing we'll receive 3 and we'll simply push back that result. Now coming to 1, there's no element which is greater than there's an element which is greater than equal to 1, but there's no element which is smaller than 1 itself. And on consulting the set, we'll receive the beginning element. Since we are receiving the beginning element, we come to note that there's an element which is greater than 1, but since it is pointing, the iterator received is pointing to the beginning, there's no element before it, meaning there's no element smaller than 2 itself, or it could be 1 here as well, right? So in that case, we'll be simply returning -1. So let's jump right onto the code. So first off, we'll create a vector wherein we'll be storing our results. Also, we'll create a set wherein we'll be placing all the elements that we come across in the array. That is the elements present to the left. I will loop over the array and we'll use the pointer. We'll consult the set using the lower underscore bound method and we'll pass in the array element itself. So this will return as an iterator, and well, this is not a block. Yeah, this would return as an iterator, and if that iterator is, let's say, pointing to the beginning of the set, it means that there is no element which is smaller than array of I itself, and that since that is the case, then we'll simply push back -1. And if that is not the case, if we are not getting a pointer which points to the beginning, then in that case we'll decrement our iterator once and we'll push in the result that is pointed by the iterator. And after doing that, we'll simply insert the array element in a set. So after this is 1, we'll simply return the result. Let's try and compile. Alright, so that was it for today's video. If you have any doubts, you can ask them in the comment section, and thanks for watching.